do a few more examples. Looking at number 5, a building that is 23 metres high casts a shadow 19 metres long. So what happens is the sun, one of its rays will come down and hit the top of the building. Now that building is 23 metres high, so we'll put that on. That sun ray comes all the way down to the ground, and when it hits the ground, that's the tip of the shadow. So the shadow is this whole part here on the ground. Okay, shadows are on the ground. It's amazing how many people put a shadow somewhere else. Shadows are always on the ground. Okay, so we're calculating the angle of elevation of the sun at this time of day. Okay, so the angle of elevation, we're looking up at the sun. So we're down here, normal line of sight is here. We're going to turn our eye or head to look up at the sun. So our angle of elevation, or theta, is going to be in there. So if we label our sides, we've got opposite and adjacent. And now we'll use tan. So it's tan theta equals O over A. Now let's sub in. Tan theta equals 23 over 19. So that will then mean that we have to get our theta by itself and get rid of the tan. So it's come over here to be inverse tan. Copy down what we had down there. And if you put that in your calculator, that's the answer you're going to get. They want the answer to the nearest degree. Your answer off your calculator for angles will always be in degrees, as long as you have D for degrees on the top of your screen. And now we're going to the nearest degree, which is the nearest whole number. That's less than 5, so this will stay. So the answer is 50 degrees. All right, let's look at number 6. So we have a person who is 174 centimetres tall and is standing 11.6 metres from the base of a flagpole. So I've drawn the flagpole. Here it is. All right, there's the flagpole. Here's the person. And that person is 174 centimetres tall, and they're standing here, okay, but I've just drawn them over there. They're standing here, and they are 11.6 metres from the flagpole. Okay, now the angle of elevation to the top of the flagpole, up the top here, is 40 degrees. Now, what you do with that is your eyesight is coming from the top of you, okay? We're pretending it's coming from the top of the person itself. I mean, the eye is a little bit further down, but we're just assuming that it's from the top of the person. Okay, so what we're going to do is just draw a dotted line across here with your red pen, create a right angle over there. We already know that this is a right angle because a flagpole is vertical and the ground is horizontal. All right, now the angle of elevation to the top of the flagpole from where you're standing, from the top of where you're standing, that's what we're marking in as theta. Oh, they've told you it's 40 degrees, so we're going to write 40 degrees in there. All right, so that's our diagram. Now the question is asking for how high is the flagpole. So they want the height of the flagpole. All right, now we're not going to be able to do this straight away. There's some parts to this. All right, so the first thing we're going to do is look at the right angle triangle we've created at the top here. So if you think about it, that 11.6, we can move it up to here. So I'm just going to move it up here. It's the same distance. And then this bit here, I'm going to call, what did I call it a minute ago? X. All right, so from here to here, I'm calling X. So now I'm just concentrating inside this triangle at the top here. All right, so let's label our sides. This is the opposite side, and this one here is the adjacent. So we're using tan. So let's write it down. Tan theta equals O over A. Now we're going to sub in. So tan, our angle is 40 degrees. Our opposite side is X, and our adjacent side is 11.6. Okay, so we're now solving our little equation that we have up there. So we're going to get rid of divided by 11.6, come to the other side, and times by 11.6. Okay. Put that in your calculator, press equals, and you'll end up with the answer I've got there. Now, to find the height, we've just found what x is, right? So we've found this bit. How are we going to find the height of the flagpole? Can you see that we're actually going to add on this bit? So we're going to add his height, 174 centimetres, to the x that we've just found. Okay, so I'm going to write down what I just found. And I'm adding on his height. Now, the only thing you've got to be careful of here is this height is in, so the number we just found was in metres because I used the 11.6. So his height has to be in metres. So we're going to convert this height to metres. We're going to a bigger unit. So we divide. Just squeeze it in here by 100 for centi. Right, 174 divided by 100 will give you 1.74. So that's the number we're going to be adding on, 1.74 metres. And if you add those up, you'll get the answer I've written there. All right, now the height, they said they wanted it to the nearest centimetre, and my answer's in metres. Now you can still keep it in metres. This is what I do. There's 100 centimetres in a metre, so if you write a 1 underneath the decimal point and a 0, 2 zeros for the 100, then rule a line. That's where they want it rounded to. Okay, so let's look at the next digit. That's less than 5, so the number before will stay as a 7, and everything else stays. So my answer is 11.47 metres, and that is to the nearest centimetre. You can give that answer, okay, because as I said, 100 centimetres in a metre, if you write the 100, rounding it to 2 decimal places is just as good. If you really want to write your answer as 1,147 centimetres, you can, but it's fine to give this answer. They're both correct. All right, now another tricky question is this next one. We have a flagpole. It's on top of a building. Okay, so what I've drawn over here is the building itself and the flagpole on top of the building. Okay, so it says at a distance of 250 metres from the base of the building. All right, so here we are at a point 250 metres away from the base of the building. The angles of elevation of the bottom and top of the flagpole are 38 degrees and 40 degrees respectively. So what does that mean? It means when we look at the bottom, because that's the first one they said, that matches with the 38. So we're over here, right? Normal line of sight straight out. If we want to look at the bottom of the flagpole, we're focusing here. So this angle going from here to here is 38 degrees, focusing on the bottom of the flagpole. The other one, the top of the flagpole, its angle of elevation was 40 degrees, because to focus on the top, you have to turn your head a bit further, aren't you? So all of that will be 40 degrees. So this is a pretty tricky question. All right, now they want to find the height of the flagpole. Okay, so they're looking for this bit here. Okay, that's the height that they want. The height of the flagpole sitting up the top there. All right, so what we're going to do is look at two triangles. The first triangle that we're looking at will be this one. The big one. Okay, so I'm looking at the big triangle to start with. Okay, so if we look at the big blue triangle that I've just drawn, we're going to find, I'm going to call all that x. All right, that is the opposite side of the angle that I have over here. So that's the opposite side. I might just stay in blue pen for this. That's the opposite side, and we do have down here the adjacent side. So we're using tan. So tan theta equals O over A. Now let's sub in. So it's the blue triangle, so the angle is 40 degrees. Opposite side I'm calling x, and the adjacent side is 250. So now we're going to get rid of the divided by 250. come over here and times by it. Sorry, I'll just stay in the black pen so we don't confuse you with all this working. Okay, so we're timesing by 250, and if you go to your calculator, you're going to get that answer. Now, I don't want you rounding, so just write the whole thing down and underline it. So now we're going to start on the next triangle. So I'm running out of colours here, but I'll just do a red triangle now. I'm looking at this smaller one. Okay, so it's the small triangle, and I'm colour coding all this work so you can see what we're doing. So we're in the red triangle. So again, we've got in the red triangle, we're looking for this, which I'm going to call Y. That's the opposite side. We've also got this 250, which is the adjacent side again. Okay, so let's look at using the red triangle. So we have tan 38 degrees in the red triangle equals Y for our opposite over 250. Now we're getting rid of the divided by 250. Come over to the other side and times by it. And work that out on your calculator and do not round it. Okay, so if you have a look at what we've just done, we found X, which is the blue line. We found Y, which is this red line. So how can I use those numbers to get my height? Think about it. We've looked at two vertical lines here, and we're looking at finding that height at the top. So can you see that we're just going to do the whole thing, which is X, minus this piece here, which is Y, and that will leave us with that little bit at the top. Right, so we're doing the X minus the Y. So I know this is a lot of writing, but we're writing it all down. Right, so it's all of this answer minus the Y answer and you will get that answer there. And now we're just looking at the rounding. What did they want? They wanted 1 decimal place. So 1 decimal place, draw your line and look at your next digit. We have a 5 here, so it's 5 or more. So we're going up by 1 here to a 5. And keep everything in front. And we were using metres here. So the flagpole is 14.5 metres high on top of that building. All right, so it's your turn to do your homework now. So remember, with anything to do with word problems, you're going to need a really good diagram to begin with, and then just use the trig ratios we've been using. Good luck with the homework.